Hello. So we had been studying about differential equations. We had seen the method of substitution. We had also seen the homogeneous equations. But what will we do if we encounter non-homogeneous equations? So this is the first method that I will be teaching you. So it involves substitution. This usually works when the differential equation is of this type. So when you have a differential equation that looks like this, a1x plus a2y, a1x plus a2y plus a3. Okay, maybe I will write it as b1. a1x plus b1y plus c1 divided by a2x plus b2y plus c2. So whenever we have a differential equation that looks like this, we have to use another method. As you can see, it is not homogeneous because over here the power of x is 1, the power of y is 1, whereas over here the combined power of x and y, because it is constant, it's 0. Okay, so the powers are different. Okay, they are not the same in each and every term. So that's why this one is non-homogeneous. So when we see that an equation looks like this, we will divide it into two parts. Okay, the first part is when a1 by a2 equal b1 by b2, and the second one, it's when a1 by a2 it's unequal to b1 by b2. So how exactly will we solve this first type, and how exactly will we solve this second type? The first one, it's fairly simple. Okay, I will just write over here substitution, and then separate the variables. Whereas this second type, I will write it in steps. Okay, so step 1, we will write, again we will substitute x equal capital X plus h. Okay, so we will convert it into a new variable x and a constant plus a constant h, and y we can write it as y plus k. Okay, so step 2, okay, substituted in this equation. Okay, you will be noticing that we will need dy and dx. Over here dx, it will be equal to dx, right, because this one, it is a constant, and dy, it will be equal to dy, again because k is a constant. So we can substitute it over there. So this is step 3. Substitute in equation 1. Okay, this one is equation 1. So after substituting, you will be seeing that it will change into this form. Okay, it will change into a1x plus b1y plus a1h plus b1k plus c1 divided by a2x plus b2y plus a2h plus b2k plus c2. Okay, when we reach this step, okay, since the constants we can easily adjust, okay, it depends on us. So we will adjust the constant so that this term is 0 and this term is 0. Okay, if this whole term is 0 and this one is 0, you will see over here that now it has become homogeneous. Power 1, power 1, power 1, power 1. Okay, so it becomes homogeneous. So this is what it becomes. So now that it has become homogeneous, we can easily solve it as a homogeneous equation. Okay, you will understand better when I will be doing the examples. Okay, so let us start with the first example, in which a1 by a2 equals b1 by b2. Okay, I will write the example here. Okay, example, solve dy dx. Okay, I will copy the question from that I've already solved. So 3x minus 4y minus 2 upon 6x minus 8y minus 5. Okay, so solution. Let us calculate what is a1 by a2. a1 by a2, it's equal to 3 by 6. It's equal to 1 by 2. b1 by b2, it's equal to minus 4 by minus 8. Again, it's equal to 1 by 2. So therefore, a1 by a2, it's equal to b1 by b2. Okay, so it is of this form. So after doing this, so now dy dx, we can write it in this way. So 3x minus 4y stays as it is. Okay, you will see why I am keeping it as it is. Whereas this one, you can take down common 2. Okay, if you take common 2, you will be having 3x minus 4y and minus 5. Remember that I say that you will have to substitute something. So this is what we will substitute. So since this is the common term in the denominator as well as in the numerator, so we will substitute it. Okay, so sometimes over here we are taking common only in the denominator. Sometimes you may have to take common from both the numerator as well as the denominator. Then you will be having a common term. But this can be done only when a1 by a2 is equal to b1 by b2. Okay, so taking common can only work when this happens. Okay, so what will we substitute? 3x minus 4y. We turn it into a new variable, which is z. So we will substitute it in this equation. If we substitute it in this equation, we will be getting dy dx. So differentiate this one with respect to x. Minus 4 dy dx equal dz dx. So dx will be equal to 1. dz dx minus 3. Okay, so dy dx, it will be equal to 3 minus 1, 3 by 4 minus 1 by 4 dz dx. Okay, so this is what we are having. Now substituted in that equation 1, you will be having this. So equation 1 becomes dy dx, we can replace it with this new value, which is 3 by 4 minus 1 by 4 dz dx equal, this one has been replaced by z minus 2, and this one becomes 2z minus 5. Okay, so we can multiply 4 both sides. We'll be getting 3 minus dz dx equal 4z minus 8 upon 8z. Okay, 8z, this one stays as it is, 2z minus 5. Okay, so dz dx, if you take this one to that side, you will be getting 3 minus 4z minus 8 upon 2z minus 5. So this is what we are getting. So if you notice, okay, we will simplify it first, and then you will notice something. 2z minus 5, okay, will become 6z minus 15 minus 4z plus 8. Okay, I hope I did not make any mistake, but even if I did, the process remains the same. Okay, you can just correct the errors in case if I made any. Okay, so 6z minus 4z will give you 2z minus 7. Okay, if you notice over here, we are getting only one variable, so which we can easily separate. 2z minus 7 dz equal to dx. Okay, so take this one to this side, take this one to this side, and integrate. Okay, so if we integrate it, how will we integrate this one? It's by substituting 2z minus 7. Okay, substitute the denominator, maybe it's equal to t. Okay, so it becomes 2dz equal dt, or dz equal dt by 2. Okay, so substitute it here, and from over here you will be having 2z equal t plus 7, which gives it z equal t plus 7 upon 2. Okay, so 2z, okay, this is actually enough. 2z is t plus 7, so t plus 7 minus 5, 2z minus 7, it is t, dz has been changed into dt by 2, and dx integration of it is log. Okay, so it becomes, okay, this 2 you can take it to that side, t plus 2 by t. 2 it is a constant, you can take it outside. Okay, it will become 1 by 2, multiply it to that side, it becomes 2 log x. Okay, so now we can just separate integration dt plus integration 2 dt upon t. Okay, this one you can write it as log x squared. Okay, integration dt is t plus 2 log t for log x squared plus, okay, so we can even write log c. Okay, c or log c, anything will do, depends on you. So t plus log t squared equal log x squared c. Okay, so t this log x squared c, if you change it to this side, it becomes like this. Okay, so now we just need to substitute t back into this equation. Okay, so t it is 2z minus 7 log x squared c by t squared, which is 2z minus 7 whole thing squared. 2z minus 7. Okay, but if you remember, we had also substitute z equal 3x minus 4y. Okay, so because we have to write the answer in terms of x and y, so that is why we will substitute it here. It becomes 6x minus 8y minus 7 x squared c divided by 2z. Again, 6x minus 8y minus 7 whole thing squared. So this one will be the final solution of the given differential equation. It is a general solution. Okay, it is a general solution because it contains only one arbitrary constant, which is c. Okay, so I hope that is clear. So that was the first type, when a1 by a2 equal b1 by b2. Now let us see the example. Okay, the second example, the example 2, which I will solve. Okay, let's see. Okay, so solve. dy dx equal 3x plus 2y minus 5 divided by 2x plus 3y minus 5. Okay, so over here if you calculate a1 by a2, it's 3 by 2, b1 by b2, b1 divided by b2, which is 2 by 3, so they are unequal. Okay, so what will we do? If you take a look at step 1, we say that we will substitute that x equal capital X plus h, y equal capital Y plus k. Okay, so we will be getting that dx equal dx d small y d capital Y. Okay, substitute in 1. You will be getting dy dx, it will become d capital Y, d capital X, and over here 3x. 3x will be 3x plus 3h. 2y, it will become 2y plus 2k minus 5 divided by 2x, 2x plus 2h plus 3y minus 3k minus 5. Okay, so we have reached up to this stage. Okay, we can first rearrange them. Okay, these are the variables 3x and 2y, and these are all constants because h and k are constants. So 3h plus 2k minus 5 divided by 2x plus 3y plus 2h minus 3k minus 5. Okay, so these are constants. H and k, they are constants and they are entirely our choice. Okay, so over here I will write down choose h and k so that this constant term becomes 0 and also this constant term becomes 0. Okay, choose them in such a way that the constant term becomes 0. Okay, so we will be getting, okay, this one also you need to write it down, so that will be complete solution. So if this one is 0 and this one is also 0, you'll be left with 3x plus 2y divided by 2x plus 3y. So after doing all this substitution, we notice something, okay, that now it has become homogeneous. The power is 1, power is 1, power is 1, power is 1. Okay, so it is homogeneous. So now we solve it like a homogeneous equation. Now let y equal v capital X. When it was small y small x, we write it as y equal vx. So similarly over here. Okay, so if you write it down, we will be needing dy dx. So dy d capital X, it will be v plus x dv dx. So this is what we will be getting. So dy dx, it will become v plus x dv dx. So 3x, it stays as it is, and y, it becomes vx. 2x plus 3vx. Okay, let us simplify. Okay, x is present everywhere, so we can cancel x from everywhere. We'll be getting 3 plus 2v divided by 2 plus 3v. We will take v to that side. So this is what we will be getting. Minus v. Okay, so if we do some simplification, let's see, x dv dx. Okay, if we subtract, we'll be getting 3 plus 2v minus 2v minus 3v square divided by 2 plus 3v. Okay, so this is what we will be getting. So 2v and 2v, they will get cancelled. Okay, so this is what we will be getting. So you will be left with 3. Take common, you will be having 1 minus v square upon 2 plus 3v. Okay, so again, we can separate the variables now. Take all the v's to this side, 2 plus 3v divided by 1 minus v square dv. It will become 3 dx upon x. Okay, so after homogeneous, we use some substitution and then separate the variables. Integrate them. How will we integrate this one? It's actually very easy. Let us just separate them. You will be having this. Integration of this one, we can easily write it down as 3 log x. Okay, this part is very important, so that's why I'm not erasing it. Okay, this one you can notice that we can write it like this: 1 divided by 1 minus v plus 1 divided by 1 plus v. Okay, so if you have 2 and 1 minus v square, you can do it like this, or you can even use partial fractions. Okay, if you use partial fractions, you will be getting this same answer. Okay, so this 1 minus v square, you can write it as 1 minus v, 1 plus v. Okay, for those of you who can even remember integration dv by a square minus b square, you can even use the standard result, okay, to solve this one. Okay, so this is what we will be getting. Okay, so this one we will be having. Okay, but to solve this integral, we will use some substitution. Okay, let 1 minus v square equal t minus 2v dv equal dt, v dv equal minus dt upon 2. Okay, so 3 stays as it is. V dv, it has become minus dt upon 2, and 1 minus v square has become d. Okay, so this is what we are getting. Integration of this one, it becomes minus log 1 minus v. Integration of this one is log 1 plus v. Okay, the minus over here, it's because of this minus, and the plus because the coefficient of v, it's plus. 3 by 2 log t equal 3 log x. Okay, so there is no more integration sign. Okay, I can write down the constant as log c. Okay, so after doing all that, okay, log 1 plus v, okay, we can okay, transfer everything to that side so that they become plus. It will become easier. So log 1 plus v. Okay, and over there it becomes log x cubed plus log c plus log t to power 3 by 2. Okay, log t power 3 by 2, and then this one becomes plus log 1 minus v. Okay, so we'll be having log 1 plus v. So everywhere it's plus x cubed c t power 3 by 2 1 minus v. Okay, so log and log, okay, we can cancel them. In fact, okay, we can do this because log is 1 1 and on 2. So we will be having this one. Now we just need to substitute all of them back. Okay, v, okay, 1 plus b, okay, we will be having, okay, we can substitute all of them. So it will become 1 plus b. V, it will become root over 1 minus t. X cube, okay, c, and t, okay, t, it is 1 minus, sorry, okay, so sorry, okay, because we need to convert everything back into y and x. Okay, so 1, this one will be y by x. Okay, so x cube, c, t, it is 1 minus b square, 3 by 2, 1 minus b. Okay, so this is what we are having. Okay, maybe I'll just write it down as b. Okay, so that becomes simpler. Now this one becomes y by x, c x cube, 1 minus b square. Okay, again v, it is y by x, y square by x square, 3 by 2, 1 minus y by x. Okay, so this is a really long problem, okay, which involves a lot of substitution. Okay, so will become x plus y, okay, divided by x, cx cube, okay, x square minus y square upon x square power 3 by 2, x minus y upon x. Okay, so this x and this x will cancel, this and this. Okay, so we'll be having x plus y, cx cube, x square minus y square power 3 by 2, and you will be having only x square. Okay, so this is what we are having. Now we need to change everything back into small x and small y. So that is why, remember that x, you can write it as x minus h plus y minus k is equal to c. Again, this one you can write it as x minus h. Okay, similarly everywhere. Okay, x, replace it by x minus h whole thing square minus y minus k whole thing square power 3 by 2, and that you will be having x minus h minus y plus k. Okay, so we can leave the answer like this, or we can actually find the value of h and k. Okay, so if you remember, h and k are given by these equations. So where h and k are given by these two equations, 3h plus 2k minus 5 equals 0, 2h minus 3k minus 5 equal to 0. Okay, if you want, you can even do further steps. Okay, you can solve what the value of h and what the value of k is. Okay, so you can multiply this one by 2, multiply this one by 3. Okay, so you will be getting 6h plus 4k minus 10 equal to 0, 6h minus 9k minus 15 equal to 0. So just subtract them. You will be having 9 plus 4, which is 13k, plus 25 equal to 0, sorry, plus 5. So you will be getting that the value of k, it's minus 5 by 30. And similarly, substitute k over here. Substituting k into 3h plus, okay, minus 10 by 13 minus 5 equal to 0. You can find out what the value of h is. Okay, so you can leave up to here. or you can solve the value of h and k, that depends on you, but this is our solution, general solution, where h and k are given by this. Until next time.